Alright, so class number 3, first order linear non-homogeneous IVP. So first order linear non-homogeneous IVP will have the following form. So it is first order linear non-homogeneous. So that is dy dt plus ATY equal to B of t, where B of t is not identically 0, and it is IVP, so it has initial condition. Let's say at initial time t0 is the value y0. So we want to solve the we want to solve DE, and then we want to satisfy this IC, right? So for this, what did we do? We multiplied by mu. Nowhere 0 continuous function, where mu was e to the integral at dt. So once we multiply mu everywhere, then we've got mu y prime plus a mu y equal to mu b. And by this is nothing but mu prime. So this was the left-hand side was mu y prime plus mu prime y. So that was mu y whole product derivative equal to mu b. That's what we did in class number 2, right? So the left-hand side, once multiplied by mu, we have this derivative of mu y, and the right-hand side is mu b. That's what we had. So in this step, because we have initial condition t0, we instead of taking indefinite interval, we take the definite interval from t0 to t, because this is an initial value problem. So we take definite integral. So going back to this, 이쪽으로 가서 부정적분 말고 정적분을 합니다. 왜냐하면 이제 시점이 뭔지 알기 때문에. 그래서 여기 다시 쓰면, so we have mu y prime is equal to mu b. That's what we have. So we'll differentiate this with respect to, we will integrate this from t0 to t. When we do that, I have to rewrite my variable of integration as s. 이제 t 쓰면 안 되고 s라고 바꿔야 되죠. So if we have integral a to x f prime s ds from your calculus, it is big F of x minus big F of a, fundamental theorem of calculus. 이것을 여기에다가 하고 이것을 big F prime s 이렇게 부르면, then we get mu t y t, 요게 이제 big F of t 이렇게 되는 거고, this whole thing, 이 전체가 big F prime이기 때문에 F는 mu times y 이거죠. So F of t is this minus mu t0 y t0. This is big F of t0. We used this star, yeah, we used this. By star, that's the left hand side, and the right hand side is still this, still the same. So because of that, we have this written right there. So mu t y t minus mu t0 y0 is a definite integral t0 to t mu SBS ds, because we changed our variable into s. Okay, so memorize. Okay, so example, find the solution of BIVP. So first of all, this is first order. They all contain t and y has power 1, so it is linear. First order, linear. B of t is not identically 0, so it is non-homogeneous. And because of this, we have IVP. So we want to write this into standard form. So to apply the formula, so it is dy dt plus ATY equal to B of t, y at t0 equals to y0. So see, since we have this, we will have to divide by, divide, right? So A of t is 4t over 1 plus t squared, and B of t is t over 1 plus t squared. And this is t0. t0 is 1, and y0 is 1/4. Then plug that into the formula. So mu t y t minus mu t0 y t0 equal to integral t0 to t mu s bs ds. That was the formula. So just plug in. So let's find mu. Mu is integral e to the integral at dt, integrating factor. So this is e integral 4t over 1 plus t squared dt. Yeah, if I take that as u, then the derivative is 2t dt. So instead of 4, I'm going to look at 2 times 2. So that is du. So we get e to the 2 ln absolute value 1 plus t squared. Absolute value of u plus c. For convenience, we can take c as 0 because I want one particular function mu. So then I can give this as power squared. Then e and ln disappears, so we get 1 plus t squared quantity squared. That's mu. Okay, so let's plug in. Y is what we are looking for. Y is our unknown. T0 is 1. T0 is 1. Y at T0 is 1/4. B of S is this. Right, so plug in. So mu y, mu of t, y of t minus mu t0. So mu t0 is 1. Y at t0 is 1/4 is equal to integral t0 to t mu of s. So that's mu of s times b of s. So it is s over 1 plus s squared ds. That's what we have. So mu of 1, if I plug in 1 there, I get 2 squared. So this is 4. And then here, one of these disappears. So this is equal to, so we get mu times y equal to, that's 1, right? So 1 plus integral 1 to t s plus s cubed ds, which is 1 plus t squared over 2 plus t to the 4th over 4 minus 1 over 2 plus 1 over 4, which is equal to t squared over 2 t to the 4th over 4 plus, and I have 1 minus half, which is 1/2 minus 1/4. So we get plus 1/4, which is 1/4 times t 4th plus 2t squared plus 1. But we are solving for y, right? Therefore, y of t is 1 over mu. What was mu? Mu was 1 plus t squared times 1/4 and this. Well, we see that that's exactly same as this. So the answer is constant function 1/4. Y of t equal to constant function 1/4 is the answer to this problem. Okay. Next example. Find the solution of the IVP. Again, we see that this is first order linear non-homogeneous IVP. So it is mu t y t minus mu t0 y t0 equal to integral t0 to t mu s bs ds, where mu of t is e to the integral at dt, right? Okay, so what's my at? Is constant function 1. So here I get e to the t is mu. And that's t0 and that's y0. So just plug in. So mu t mu y minus mu t0 is e squared, y t0 is 3 equal to 2 to t mu of s, b is 1 over 1 plus s squared ds. So y of t is first, if I move the constant to the right-hand side, I get e to the s over 1 plus s squared ds. And then we will have to divide this by mu. So now that becomes e to the minus t. Well, this integral cannot be integrated analytically. We'll have to do numerical approximation by Taylor series. Okay, we can't find its explicit. We cannot find its integral. We cannot integrate this. We cannot find its antiderivative as an explicit formula. That's not possible. Okay, so we'll have to leave the answer as it is. So that is the answer. And then later we do numerical approximation there. In your 수치 해석 그런 클래스에서 나오고 나중에 이제 이거를 이제 시리즈로 파워 시리즈로 어떻게 approximate 할 것인지 나중에 이제 나옵니다. Okay?